Hi there, welcome back. Today we are working on lesson 4.5, comparing properties of functions. We have the same standard and the same essential question, so off we go. Our video then starts with some fill in the blanks that we need to make sure that we understand. So to compare functions, the word functions, find and compare the rate of change of one function to the rate of change of the other function. Recall that the function can be given using an equation, table, graph, or word. So those all go in the blanks. And then you can compare the two functions once you know the rate of change. So we're going to find the rate of change from graphs. We're going to find it from a table. It may be in the word problem itself. Here we go. Student Council is hiring a DJ for the school dance. The first DJ charges $25 an hour. The second DJ fees are shown in the graph. Compare the functions for each of the DJs by comparing their fees. So what does our Y label look like? Our Y label is fees in dollars. What does our X label represent? The number of hours. So you're filling this in. So our rate of change will be the fee over the number of hours. So for the first DJ, our fee is $25 per 1 hour. So it's $25 for the first hour, $50 for the second hour, $75 if he works 3 hours, and so on. We don't need to make a function table to know it's $25 an hour. All right, we are going to take the rate of change for DJ 2 through the graph. We've got a dot right here at $30 over 2 hours. So $30 over 2 hours gives us a rate of change of, or unit rate of $15 per 1 hour. And then we can compare them. DJ 1, it says compare the functions for each DJ by comparing the fees. DJ 1 is more expensive than DJ 2. Don't know if he's better at it or not. The math shows us that DJ 1 is more expensive. All right, Damon. Damon's earning for 4 weeks from a part-time job are shown in the table. Assume that his earnings vary directly, which means it's going to be the same per hour with the number of hours worked. So we're going to have to do some math. Our pay over hours is what we're looking for again. So $112.50 minus $90 is going to give us $22.50. 15 and 12 is over 3 hours. And that reduces to a unit rate of $7.50 per 1 hour. I assume that you could find that on a calculator if you had it out too, just trust me. So that's Damon. Or job B will pay him $7.35 per hour. Which job has the better pay? So the job in the table is 15 cents higher or better for Damon to work. Writing some sort of sentence to explain why this job up here was better than the job that's $7.35 per hour. All right, Melanie. Melanie charges $7.50 an hour to babysit. The table shows Louisa's charges for babysitting. Compare the functions by comparing their rates of change. So again, we have money that she babysits or she earns. And then we have number of hours, just like we did on the first problem. Melanie's unit rate is $7.50 an hour. So Louisa we have to find. It looks very easy to find. That's $8 per hour for Louisa. Back to the question in the problem. Don't forget to go back. Who would you have babysit? Well, Melanie is a cheaper hire for a parent by 50 cents an hour. Okay, just make sure we answer a question. We explain why Melanie is a better hire than Louisa. Although Louisa might be a better babysitter, you never know. Tom and Lisa. Tom and Lisa each spent an afternoon biking on neighborhood trails. The distance y Tom traveled can be represented by the function y equals 11x. So 11 miles in 1 hour, 22 miles in 2 hours, 33 miles in 3 hours. The graph then shows Lisa's distance. Who traveled the quickest? So we've got to put in Tom and Lisa into the chart. There's really no need to make a function table. We know that Tom is 11 miles for 1 hour. And then we need to look at the graph to find Lisa, 24 miles over 3 hours is going to be a unit rate of 8 miles per 1 hour. Back to the question, who traveled the quickest? Oops, sorry. Tom traveled faster than Lisa by 3 miles, I'm off the screen, per hour. There we go. And we are done. Have a good day.